Welcome back to the series, guys, where we are discussing the solutions of the activity questions. We were solving activity 1.2, and in this video, we'll be solving question 6 and question 7. So let's get started. Here we have question 6 with us, and we have to choose the set of correct options. So let's analyze each option one by one. Starting with the option 1, we have if A is a square matrix of order 2 and A square is equal to I, then the only possible cases for A are A equal to I or minus I. So we either have to prove this point or disprove this point. See, so to disprove this point, we will have to give any counter example. So do we have any counter example? So if we look at any matrix like this, -1, 0, 0, 1. And now if we try to calculate the A square, the A square in this case is -1001 times -1001. So if we take the product, it's going to be -1 times -1, that is 1, plus 0 times 0, that is going to be 0. -1 times 0 and 0 times 1, all is going to be 0. 0 times -1 and 1 times 0 is going to be 0 again. 0 times 0 plus 1 times 1 is going to give you 1. So we indeed showed an example where A was neither I nor minus I, but still A square was equal to I. So this option is incorrect. Though we have a special name for such kind of matrices, and the name is involutory matrices. Involutory matrices. So what are involutory matrices? Matrices such that A square is equal to I. Now, if the value of A square is equal to I, can you say something about A cube? A cube would be A times A square, and your A square was just I. So it would be A times I, which is I again, which is A again, sorry. And if we talk about A4, so A4 is going to be A square times A square, which is going to be I times I, and that is going to give you I again. So in involutory matrices, you can say that if the power of A is odd, then you are going to get A again. But if the power of A is even, in that case, you will get I. So that was about the option. Now let's move on to the option 2. In the option 2, it is given that if A is a square matrix of order 2 and A square is equal to 0, then the only possibility is A is equal to 0. So again, we have to either prove or disprove this point. So first, let's try to think of any counter example. So let's suppose we take A equal to 1, -1, 1, -1. Now, what would be the value of my A square? My A square would be A 1, 1, -1, -1 times 1 minus 1, 1 minus 1. Let's see what would be the product. So 1 times 1 is going to give me 1. Plus -1 times 1 is -1. So 1 plus -1 would be 0. Similarly, we can do the calculation here as well. It is going to be -1 plus 1, 0. It would be 1 minus 1, 0. And then it would be -1 plus 1 again. That is to give you 0. So again, we gave an example where the value of A square was, the matrix A square was equal to 0 when the A was not 0. So again, we have a special name for such kind of matrices, which is nilpotent matrices. Nilpotent matrices. So matrix A can be called a nilpotent matrix when A square is equal to 0. So matrices such that A square is equal to 0. So this would be a nilpotent matrix. Now, one thing we can see from here, that if a square is equal to 0, can I say something about a to the power n? Yep, I can. So a to the power n is nothing but a square times a to the power n minus 2. So because a square is 0, I can say that it is 0 matrix multiplied by n minus 2. So any matrix multiplied by the 0 matrix, it's going to be 0 again. So this is something you can call about the nilpotent matrix, where n is not equal to 1. We are not saying this about the n equal to 1 because here we saw that a1 was just this matrix. But yeah, for a2, a3, a4 or any other power of a, the answer is going to be 0. So we saw the option 2 is incorrect as well. Now coming to the option 3. If A, B are square matrices of order 3 and A plus B is equal to 0, then B is equal to minus A. Yes, sir. It is true. Why? Because if you are given A plus B is equal to 0, you can write it as B equal to minus A. This is correct. Now, coming to the option 4. You have A is a scalar matrix of order 3 and B is a non-zero square matrix of order 3. So about B, we know that it is a non-square matrix, non-zero square matrix, and A is a scalar matrix of order 3. And AB is equal to then in and AB is equal to 0, then it should imply that A is equal to 0. So let's see what are the information given to us. The first information that is given to us in the option 4 is A is a scalar matrix. Then about B, we are given that B is a non-square, non-zero square matrix. Square matrix. And then uh, there is another information that AB is equal to 0. Okay. So let's analyze all these equations one by one. So the first thing is A is a scalar matrix. So if A is a scalar matrix, then we know any scalar matrix can be written as the scalar multiplication of some constant with identity matrix. So that means I can write A is equal to some k times I, where k is some scalar value. Now, if I have AB equal to 0, I can write A as k times I into B equal to 0. So, here I can write it as k times I times B equal to 0. And here I will have I times B as B again. So, B k into B is equal to 0. Now, what can I deduce from here? That the value of kb is equal to 0. So now let's take two cases. So the first case is either k is equal to 0, or the second case is k is not equal to 0. So first let's check what was asked in the question. It was asked in the question that a is equal to 0. Okay. So given that k is equal to 0, we can deduce if k is equal to 0, then a was just k times I. That would mean it is just 0 times I, hence it is 0. This 0 is a scalar quantity here, and this 0 here is a matrix. Now, what would happen if k is not equal to 0? See, if k is not equal to 0, then it means I am allowed to multiply both sides with 1 by k. Okay, that means I can allow, I can I am allowed to multiply both sides by 1 by k. That means I can write this equation as 1 by k times k into b is equal to 0 times 1 by k. Now, what that would become? In the next step, I can write it as 1 by k and k will cancel out each other. It would just be 1 times b, that is b, is equal to 0 matrix times some constant would be 0. So b is equal to 0. That is the second thing that we are getting. But it was given to us in the question that b is not equal to 0. That b is non-zero square matrix. So this is not possible. This case is not possible as b is not equal to 0. It was given to us. So what we can deduce is this case is not possible. So the only possible case is this, where the value of a is equal to 0. Hence the option 4 is correct as well. This was your question 6. Now moving on to the question 7, where we have a square matrix of order 2 where the first and the second column are denoted by C1 and C2 respectively. And we also have a 2 cross 2 matrix B denoted by B11, B12, B21 and B22. Now the options are regarding the product matrix AB. So let's take A as some 2 cross 2 arbitrary matrix, that is A11, A12, A21 and A22. Moving on to the B, we have B as B11, B12, B21 and B22. So now let's take the product of these two matrices. So for the 1, 1 component of AB, we will take the first row of A and the first column of B, such that we are multiplying the first component of the first row of A with the first component of first column of B, that is B11 times B11, and then taking its sum with the second component of first row of A with the second component of first column of B, that is A12 times B21. Now, for the 1, 2 element of AB, we will take the first row of A and the second column of B. That means A11 will get multiplied with B12 plus A12 will get multiplied with B22. Now, for the 2, 1 element of AB, we will take the second row of A and the first column of B. That means A21 will get multiplied with B11 plus A22 will get multiplied with B21. Now, for the 2, 2 element of AB, we will take the second row of A and the second column of B. That means A21 will get multiplied with B12 plus A22 will get multiplied with B22. So this is our product matrix AB. So now let's check the options. The options are regarding the product of A and B. Here the first option says the first column of AB is B11C1 plus B21C2. So let's analyze the first column of AB, that is this one. Here it says the first column of AB is B11 times C1. So let's see, it is B11 times A11 and then B11 times A21. So if we check A11 and A21, they actually denote the first column of A. Here we can check that C1. And now it says, then you take its sum. Yes, we are taking its sum with B21 times C2. So here we are multiplying B21 with A12 and then B21 with A22. That is with this C2. And we can check, yes, it is C2. Similarly, if we talk about the second column of AB, which is there in our option 2, it says we are multiplying B12 with C1. So let's see, we are multiplying B12 with A11 and B12 with A21. So A11 and A21 denotes the C1, and then it says, then we are taking its sum with B22 multiplied with C2, and here we can see that B22 is multiplied with A12 and A22, which actually denotes the C2. So here we can see that option 1 and option 2 are correct. What about option 3 and 4? So both these options are incorrect. Why? So option 3 says in the first column of AB, that is this one, B21 is getting multiplied with C1. But here we have seen that B21 is actually getting multiplied with C2. So this option is incorrect. And the option 4 says that B22 is getting multiplied with C1. And here we have seen that B22 is being multiplied with C2. So this option is also incorrect. So that was all about this video. We'll see you in the next one.